Okay, so let's look at these problems. There are two pretty simple ones. Notice that they're both cantilever beams, and I want to construct the shear force and bending moment diagram. Now we know something about cantilevers. What do we know about cantilevers?
No shear on the outer edge.
Or maybe here on this one because there's an applied load. But where's the maximum moment going to occur? At the cantilever. Where's the maximum shear probably going to occur? At the cantilever. So we kind of know that starting off. Now, just to speed the process up a bit, I'm going to go ahead and just calculate quickly what the shear force and the bending moment are at this cantilever. I don't think it'd be hard for you to figure out that the shear force is P and that the bending moment is PL. Now, what kind of shear force is that? Positive or negative? Positive. What kind of bending moment is that? Negative. So when I start construction of my shear diagram, what's the starting value for the shear at the cantilever? P. So let me just remind you that what we want to do is we want to look at the change in shear is going to be the area under the load diagram. So let's look at this area here. What's the area under the load diagram from 0 to L? 0. So there is no change in shear. So if we start at positive P, we better end at positive P. And the corollary to that is that the slope of the shear diagram is given by the value of the load. And what is the value of the load from 0 to L? 0. So again, what kind of curve has a 0 slope? Horizontal line. So this beam has constant shear. What happens right here by this load P? We kind of talked about that before, but if I look at just this little piece, let's go over here real quick and look at a little free body diagram of that, just so you'll see it. So I've got a little chunk of the beam. We'll make it really small. And on the right edge, we have that load P applied. And on the left side, what's positive shear on the left side? Up or down? Up. So if you sum forces here in the y direction, what do you get? The shear is acting up, the force P is acting down. It says the shear is equal to positive P. And what do we get it to be? Positive P. So that one looks good. So let's move on to the moment diagram. So now we have what we think is a good shear diagram. We can now predict that the change in moment is the area under the shear diagram. So what is the starting value for our moment? Let's see. It looks like it's PL, and that's a positive or negative bending moment? Negative. So I'm going to start at minus PL. So the change in moment from 0 to L should be the area under the shear diagram. What's the area under the shear diagram? It's a rectangle. Base times height. Base is L. Height is P. So positive PL. So if I start at negative PL and I add PL to it, I should get 0. Does it make sense that the bending moment would be 0 at free end? Yes, it does. In fact, we probably should have marked that point down as one that we needed to hit. And what is the slope of the moment diagram? It's equal to the shear. What's the shear value at the beginning? P. That means I'm going to start at a positive slope of P. And does that slope change?
Yes.
No. So it's constant slope. Positive. So in this case, this would again be P to 1, and there's my moment diagram. Besides giving you the reactions, how many equations did I really do? I applied these relationships, but usually the calculations are so simple you can pretty much do them in your head. Or let's move this other way. Now we have an applied moment. So if I sum forces and try to find my reaction here, what will it be? 0. There is no shear. And with this kind of reaction, I'm going to get a reaction moment here of m naught. Right? Some moments, those cancel out. So this is going to be challenging. Let's draw the shear diagram. So what's the shear? What's the shear at the left edge? It's 0. What's the shear at the right edge? 0. The change in shear is the area under the load curve. What's the area under the load curve? 0. So there's no change. I think you can connect those. So there's no shear in this beam. Now let's go to the moment. So what is going to be the bending moment at the beginning? What kind of bending moment is that? Positive. So we're going to start off at a moment of m naught. By the way, what kind of bending moment is that on the right-hand side? Positive. We better hit m naught. For that to work, then the area under the shear diagram better be 0, is it? Looks like it to me. So that works. And what's the slope of the moment diagram? It's equal to the value of the shear. The shear is 0. What's 0 slope again? Horizontal line. Be careful when you say straight line, because a straight line can have a slope. So there's a moment. So this is a problem, pretty simple one, that has no shear and constant moment. What's the likelihood that one of those problems will be on the exam?
0.
With 100% confidence, I can say it's 0. I want to start slow and build up.